Hi, everybody. I would like to ask my colleagues, the panelists, to join me. Ankur from Nokia, Preston, Google Cloud, and Alex Solly.
Hey.
Great, thank you,
Hey,
please.
Thank you.
Excellent. So this is going to be an interesting discussion, and I'm hoping that you'll have a few questions for us as well. So we're talking about connected vehicles, connected cars, and the infrastructure around them. There's quite a lot of work, and you hear a lot about what's happening, particularly in IoT solutions, related to these vehicles becoming more and more like computers on wheels. But then what's around them, the environment they're going to operate in, still includes the classic vehicles that my friend Bill Hoffman still drives, as well as infrastructure around them that's probably 100, 200, 500 years old, or maybe even older. So how do we integrate all of that together? I'm happy to have my colleagues here to explore not only the challenges, but also the opportunities and the use cases. As Richard Solly yesterday mentioned in his opening remarks, that it is about solutions, and you're here to hear from us about this. I'm hoping this discussion will drive us into that and give you some of those examples. So I'm going to ask my colleagues to give a brief intro, and then when you do that, go and tell us a little bit more about, can we get those vehicles out there while the infrastructure is not ready yet? Sure. So Ankur, why don't you go first?
Sure, Sai. Thank you. Hello, everyone. My name is Ankur Bhan. I'm head of Wing program at Nokia. Wing stands for Worldwide IoT Network Grid, that we are establishing a communication infrastructure for global IoT deployments, and particularly for connected cars and autonomous vehicles. One of the big barriers that we see out there is a seamless connectivity to really enable the autonomous vehicles and full capabilities of AVs, and Nokia is really investing a lot in enabling sort of an infrastructure so we all realize the full potential of AVs out there. And to your question, are we fully ready there yet? So if I look at AV, this is probably one of the most complex and challenging use case that you find across an IoT, because it's not just about the technology. When I look at the technology components, whether it's a device or connectivity or computing, I get a lot of confidence out there in the industry and see most of the building blocks are there. But the challenge is much beyond into security, privacy, regulatory, and one of the most important aspects for AV is to ensure the security of the users in the car. And for us to really be ready for mass deployment, it has to be perfect, and nothing short of perfect will work. So I think there will be deployments. We already see connected cars and autonomous vehicles in isolation, but when we are talking about the mass deployment, I think we are still a long way away, but I see a lot of work happening already, whether it's, I come from a telecom industry, I see telecom industry now getting pretty close to automotive OEMs. We are on the same table discussing the challenges. There are developments and advancements happening in the enabling infrastructure to make that future ready.
Great, thank you, Ankur. So Preston, should I call you Preston or Iron Man?
Yeah, no, I'll turn this off.
You got to tell us a little bit what you have there, right?
It's just a little blinky light, 3D printed of cloud platform. So I work at Google Cloud Platform. I'm head of IoT Solutions, and I do a lot of work with customers, sort of integrating across this vast array of end-to-end that is IoT, and then brings me to a lot of the other parts of Google and Alphabet that are touching into connected vehicles. So we've got, Google has split many projects into these separate Alphabet companies. So many of you have heard of the Google self-driving car. That's now called Waymo. It's a separate company. We've got a smart city initiative called Sidewalk Labs. All of these touch on this sort of transition of infrastructure for automotives and cities. And I think what I'll say briefly just in the introductory period is that I think what we're seeing is a lot of potential for deriving insight of the infrastructure through things like vision. So in other words, instead of trying to worry about re-instrumenting thousands of miles of highway with specific purpose-built sensors, we've been driving street view cars around the country, and from street view vision, we can detect things like traffic light positions, street sign positions. A whole lot of that infrastructure can be located, tagged, and organized as data without it being specifically upgraded for smart vehicles. And so that idea of deriving things like patterns and positions of meaningful events from lower level signals that we already have access to without newly instrumenting it all is something I think the transition is.
This is great, Preston, because we're in a city in Barcelona that has a lot of great design and architecture, and I think it's a multidisciplinary type of effort that we need here, right, when we talk about these types of issues. And as Ankur, you were saying, it's not just a technology issue. So I'm going to go to Alex. So Alex, before you talk, I enjoy spending time with you, and we've worked together on a lot of issues. One of the things I find really fascinating in the way you're looking at things different from me. I mean, you're considering not only the aspects of regulation and policy and so on, but you're also looking at security and safety, the way Ankur was talking about. They're really important as we start to deploy these new technologies and these connected vehicles into the market. So why don't you introduce yourself and also consider that question I was asking you.
All right. I'm Alex Narsoli. I'm a connected vehicle analyst, independent consultant. As far as cybersecurity goes, it's definitely an important question going forward. It's one we're actually dealing with right now. There have already been incidents where people have found crucial vulnerabilities in vehicles that are not autonomous, but they're connected. And luckily, so far, all of those exploits have been found by white hats. And to follow on Anor's point about how this has to be perfect, or at least near perfect, if people can't trust that the cars that they're riding in, as opposed to driving in, aren't going the direction they're going, or if something's going wrong, they're going to be really worried about the cybersecurity going in the future. And when I'm saying cybersecurity, I don't just mean some guy hacks the car from the outside and everything goes south from there. There was actually a piece of research recently that showed that if you put tape on a stop sign, specifically the red octagon, in such a way, a car will misidentify the sign as a speed limit sign, and the same is true of putting tape on a speed limit sign on a stop sign. So imagine you're going on the highway, and your car sees the sign, and for some reason it misreads the speed limit sign as a stop sign. That's going to cause a few accidents. There needs to be a lot of work done to make sure that people trust these cars not to make errors such as that, making sure there's backups to make sure this, like, should this sign be here? Or making sure there's no man-in-the-middle attack, which is saying that sign's not what you think it is. It's going to be a big issue going forward, something that everyone's going to have to think about to make sure this all works out.
That's a very good point, Alex, that you bring in terms of that kind of integration, Preston, you're talking about in this transitional state that we are at the moment, right? So, Ankur, I'm going to come back to you. With a lot of these systems, we think about them as either distributed or centralized. For those of you who are technologists, you think about these architectures, particularly with IoT. We talk about cloud. Preston, you know a lot about that, but also about edge computing and so on. So how are those control systems? What are the options that we have, and how do you see those?
So absolutely, I think that's a great question, right? So I think there is a lot of debate in the automotive industry at the moment whether we keep the centralized or the decentralized control system, and there are kind of arguments both sides of the discussion. And I think you can see the merits of decentralized, where a lot of sensors are building a lot of compute, so they can recognize the edge processing at the edge itself. But also when you look at options available with the low latency connectivity, and you see that you can take the raw data and sort of feed that to other systems, so you can do a better traffic management and not just the immediate vicinity of the car, then there are arguments for the centralized system as well. And I think it's also an economic question as well, right? So depending upon the car model, whether you're talking about a budget segment or a luxury segment, in the short term, there will be some sort of any economic decisions driving that argument as well. But I mean, one thing is for sure, there is a lot more processing happening at the edge, but we need to also be smart in terms of which data we can send out to the cloud for processing, how that can add value to the overall ecosystem to reduce the emissions, to for the overall city to better manage the traffic and beyond the immediate line of sight of the car.
That's a really good point. I think, Preston, you want to add to that, right?
Yeah, I think it often is presented as an either-or decision, when in fact I think in reality it's going to be a hybridized blend of both. So in other words, you can think of a given task or behavior in a car as being something you need to deliver to the user or to the vehicle. And you can think of that task as being dual implemented both locally on the edge side as well as potentially in the cloud side. And depending on the task and your mindset, you can see that as being either cloud enhanced, if you've got the connectivity and you've got the latency availability, just use that. Or you can think of it as cloud first with a local fallback. And the idea is that you would branch the request simultaneously to both implementations and use whichever is best or fastest. But that doesn't mean you have to a priori decide everything about your system needs to be purely edge or purely cloud. And you should try to basically say, we will use the best sort of result for this task we have at our disposal at the time we need it, right? So you can put timeouts and say, if we do not get a response back from the cloud, which we think is the better answer, but we need one within 500 milliseconds, and if we don't get it, use the local implementation, which we have already pre-calculated in anticipation that we may not get the cloud response back. So I see it's too often put as an either-or debate when I don't think it should be. Yeah.
Are there any regulatory implications there? Any policies that are going on in different states or different places? Alex?
In terms of regulation, there is a difference between the United States and the European Union that generally the United States is trying to pass legislation that enables it to happen, whereas the European Union is trying to actually promote its adoption. There's also the right issues that a lot of it's still in the United States, the local and state level, and in Europe, still on the national level. If you were to try to test an autonomous vehicle that would drive from California to Florida, you would come into issues like in California, there still needs to be a wheel on the car. In Florida, there's a question as to whether or not the person who's operating the car is the person who's inside the car. And even now, a year later when it was 44 states, even now, a year later, now that more regulations have been introduced and the federal government is trying to go into this as well, in a majority of states, autonomous driving is neither forbidden nor permitted. There just aren't any laws on the books. And there's been some movements in Europe, as the Vienna Convention, which a lot of countries adopt, which governs this sort of thing, says used to say that the person at the wheel has to drive, but they're trying to alter that. Then there's going to be some more issues in Europe, especially with Britain, which was more in favor of just letting it happen, now leaving the European Union. We'll see how that happens.
So that's a good point, Alex. When I talk to a lot of car manufacturers, they tell me most of these vehicles are capable of a lot of things, and most of the time we use probably 15% of their capabilities. And Preston, going back to the experience that you guys have in enabling more solutions. I mean, we have a lot of people here that are possibly interested. What do I do with that data that comes from these vehicles or the surrounding information? So perhaps there are ways to kind of explore bringing it to 50% or maybe more?
Well, I mean, there's always limits on how much data. I mean, even though, say, we may be able to provide the storage for all of that data, there's, the network is always, we found always the limiter, right? And as better as it gets, you always can produce more. So what you need to do is be smart about when and how you move all of that data. So the idea that we're seeing some customers use is to move the full resolution of data from test vehicles into the cloud, where you can then run many different sort of simulation replays of it and find out what is the right degree of information compression, right? So depending on the system or the models that you're running, you may get away with being able to transmit 50% as opposed to 100%, right? And then you'll work with the network you have to basically fill the pipe. But you want to fill it intelligently with the data that's going to provide you the most effective, runtime against that data. And so, but what we see is basically iterate on copies of your full fidelity test car data, right? Move that slowly if you need to get it into an environment where you can iterate, and then fill the pipe with the most useful data.
Excellent, good point. Ankur, you want to add to that?
Well, clearly, I think the networks are in the state of sort of evolution. So, cars and autonomous vehicles specifically put a lot of requirements in terms of how networks are being evolved. So we are at a stage where 4G networks do exist, but all the 5G, in preparation of the 5G launch, then all the requirements about low latency, supporting the autonomous vehicles, that is what is really driving the network evolution. And we now see that, V2X kind of becoming, cellular V2X becoming more of and the automotive industry kind of converging on that to support the multiple use cases. So I would say that yes, network is sort of a limiting factor, but there is a lot of development happening already on that as well.
So there's a lot of disruption as well, right? And with the newcomers in terms of changing perhaps the services, et cetera. So I have another question for you, Ankur. So we were talking earlier about, you're trying to cross the street and the person driving the car stops and smiles to you and say, go ahead. So now when we look at these vehicles, there's no one driving and we want to be able to figure out how are they interacting with you or with the environment. So are we going to put a screen in front of them to kind of smile, or what are we doing?
Well, that's the interesting bit, right? So for AVs, I think analytics and security is going to play such a big role, right? Yeah. Because so many things that we take for granted, a pedestrian crossing the street, and then you see the driver, he smiles at you or acknowledges your presence, and then you know that you could possibly cross. But in an AV, that sort of thing is not there. So how do you really build some sort of a user interface that blends well with the natural environment? And that's where AI needs to really play a lot of role. And I'm sure you guys must be doing a lot of work around those areas as well.
Yeah, I mean, it's interesting, this idea of the pedestrian crossing the street, because I think one of the challenges is going to be, as a society, wrapping our heads around the statistical fact that there's no such thing as 100% perfection, right? I mean, there is no software written yet today in the world that is completely bug-free or never makes a mistake. And so the question of whether we as a society will accept a statistic improvement in safety. I mean, safety is always brought up as one of the values of an autonomous car fleet, in that we can lower car deaths, et cetera. And I think anyone who's looked at this academically knows that that is a legitimate, reliable sort of projection of what will happen when self-driving cars are more numerous. That doesn't mean that that number goes to zero. That doesn't mean that car fatalities drop to zero, that there will never be an accident. But as a society, we accept fallibility of fellow humans far more easily than we accept fallibility of technology. In other words, we all accept that drivers make mistakes. We all accept that, driver will get into a fender bender, and we've all been on both sides of that at one point in our life to some degree. And so we give room for humans to make mistakes that I feel we will not for a long time be giving room to the technology to make mistakes. And so that transition of understanding that there will be accidents in self-driving cars, but that as a society, statistically, we're all safer. It's going to be a thing that for many citizens will have a hard time wrapping their head around, and I think that's going to be a very long transition.
I agree, Preston. So let's give some numbers to our colleagues here in the audience. Alex was telling me 94% of all accidents in the U.S., right?
In the U.S.
are due to human error, and Ankur, you were telling me that 1.2 million deaths globally, right, worldwide,
globally
every year are occurred. I guess, human error as well?
And that statistic has not changed.
Yeah.
So
I know some people here would disagree with us, but if we remove that factor and we are all fully autonomous, is that going to change?
I think so, right? As Preston was saying, certainly autonomous vehicles should really bring down that, right? And that's what the entire ecosystem is trying to achieve. But I think the point that he made was really great, in terms of, do we as humans give technology that even a small margin of error, and it'll take some time for society to transition to that stage. And also when AI becomes more prevalent, of course, autonomous vehicles is one example, but this will happen across use cases in many other areas that we touch as well. So we'll see how that evolves.
Great. So as you bring in more machine learning and AI, as you were saying, and looking at the example that Alex gave us, you're, the car or the autonomous vehicle is trying to detect a sign and recognize it, but that sign has been tampered with. I mean, how do we deal with that? I mean, Alex, what's the plan? I mean, both of you.
Well, there's several ways you could try to tackle it. I mean, one way is to try to do backups, like adding sensors to the sign so that the car might say, that looks like a stop sign, but the sensor says it's actually a speed limit sign that says maybe 45 miles per hour or whatever the kilometer version is. I'm sorry, I'm American, I don't know the number off the top of my head. That's one way to get around it, although you'd have to retrofit all the signs. Another way is to find some way to tag GPS information saying, there's a sign around here that says that, and then try to use all sorts of backups so that even if one or two of them fails, there's something saying, okay, there's clearly something going on here, we have to be sure. And some more better technology might help, making sure the cars can better recognize, okay, that sign is sort of red, and while most of the octagon is gone, I'm pretty sure that's a stop sign.
Yeah.
And I'm on a freeway, right? Like, so I think that context is key. And that's where the idea of as these models improve, and as an example, the Google speech translation, right? The thing that can take spoken words and translate it to written words, builds context. So if I were to say, hey, let's go to the market, pick up some meat, and then meet at my house later, I just said the word meat twice. But it will accurately translate meat into M-E-A-T, like the steak, versus meat. And so that idea of informing the AI with more and more context, that's what you would use. If somebody went to make a speed limit sign look more like a stop sign, you and I would sort of say, well, no one's going to put a stop sign at a freeway when I know I'm doing this. And so it's really about broadening the context available to these models.
So, Preston, you're saying those machine learning algorithms or deep learning, whatever AI techniques you're using need to be a little bit more, they need to learn, they need to be smarter about that.
Yeah, so for example, our current vision APIs not only can do things like support recognizing objects in a photo, but actually recognize the whole scene, right? It's a boy playing on a beach with a dog. And that concept of recognizing that there's play happening, it takes another order of sort of context awareness composed from all of the objects, not just the object recognition within the scene. So in the stop sign case, it's the context of a stop sign recognized as the shape and the pattern, but in the context of, am I in an urban city street? Are cars stopping in front of me for this thing? All of that becomes signal into the model.
Excellent. So my other question, we talked earlier about some really interesting numbers and consortium and some smart highway testing. This is kind of related to both cloud and edge and latency, particularly latency, which is important. You want those systems to react in real time, right? So how do we, can you tell us about some of these examples, please?
Absolutely, and just also building on what Preston was saying, that the context is going to be so important for AVs or mass deployment of autonomous vehicles, because they need to really understand not only from their immediate vicinity, but also what may not be at the line of the sight. You know, the car coming from at the corner that you cannot see yet, but will become apparent to your radars in some time. And I think kind of for that as well, the telecom networks need to evolve. So lately, Nokia, we've been doing trials with consortium of Deutsche Telekom, Nokia, Continental in Bavaria, in Germany, where we've been testing vehicle-to-vehicle communication and also vehicle-to-infrastructure communication, and achieving already the results with existing LTE infrastructure with 20 millisecond latency, right? So it's a huge improvement over what we see in the traditional LTE networks. And we all know the promise of 5G, where we are talking about sub 3 millisecond latencies type of scenario. And when those networks are fully deployed and operational, then I think network will not be such a limiting factor, and that will give rise to additional sort of context and AI that we can do with that infrastructure. Excellent. So I think we are very hopeful that advancements in network will kind of enable new level of context and AI that is possible.
So Preston, you could use the example from a cloud point of view that you have some experience with as well, right?
Well, I mean, I think the focus on latency is key here. And when we talk about network and limitations, it's important to recognize one of throughput and one of latency are different network metrics, right? And so the reason these improvements in latency are key is you may still be limited in full throughput of raw data, but that's not really what's important in some of these autonomous behaviors. What you want to do is have these higher order derived events that might use edge processing and then relay those between these different components, whether it's car to car or car to infrastructure. And the best case numbers need to then be built into end-to-end numbers, right? And so you've got, what we often deal with is depending on which of the pieces of Google's network infrastructure you hit, which is why we put so many pieces in so many far-flung distributed spots. You know, we've got points of presence in pretty much every metro, is because you've got to take the network latency, add it to then it gets onto our network, then to the compute platform in the cloud, and then back again. And so these combinations of latencies are what matter. And so every shaving of an improvement in the networking that is being worked on at the telecom layer is actually multiplied 5 or 10 times as you do round trips and other things like that. So it's more than a 10% gain might be more than a 10% gain sometimes.
Okay, great. So I have one last question, and then I want to give some time to the audience to ask us some questions. So to build autonomous vehicles, you need an ecosystem. I'm hoping they agree with me, but it's also complex. So you need standards and open source and potentially kind of ways to get everybody to work together. What's your view on that, and how do you see that happening? Any examples? And you just mentioned one, but kind of taking it to another level, yeah.
So sure, I think autonomous vehicle will provide sort of a new set of interactive digital services. It'll be an extension of your smart home, smart office into the car. And I think the possibilities are sort of unlimited, right? From enterprise scenario, but also from a consumer standpoint. You know, if you're not driving, then you're consuming content or kind of looking at some digital services there. So I think the ecosystem is really important because there are going to be number of possibilities in different kind of environments and geographies. And it's really important to bring that ecosystem together in the car. And I hope, you know, there will be some sort of more standardization effort to really drive that further.
Just briefly, I mean, maybe I'll ask a question to you, which is I've recently been learning more about eSIMs and the ability to decouple the way equipment joins the network in a way that's not needing to be as pre-provisioned. I think that's an exciting on the front on the telecom side. Open source, I'll just mention that what we've been doing a lot is open sourcing frameworks like TensorFlow for the machine learning, right? So we are trying to democratize as much of the technology around machine learning as possible.
Great.
As far as
Alex?
ecosystem goes, I think more in terms of what the infrastructure is going to look like, because you have a bunch of different companies that are in this field, like Google, obviously, but also a lot of the car companies have been working on their own operating systems, their own ways of recognizing signs and such. We'll have to figure that out. And what's going to change? Like if there's fewer people owning an automobile, someone's going to have to own them if we're all going to rent them from someone. And also changes such as, in the near term, we're still going to be using petrol or gas to power our cars. So how are we going to tell our cars which gas stations should we use? Because if they're all going to the cheapest gas stations, that's going to cause a lot of long lines, as well as issues such as how are they going to tell people, okay, we need this much gas, how much do I pay for that gas, etc. Are these cars just going to be driving around constantly, or is there going to be a place to park? There's a lot of questions that are going to have to be answered as far as the ecosystem goes, never mind what the signs are going to look like and such.
Great. Thank you, Alex. So why don't I open it up for a few questions. I got one here, one here, one here. Wow. All right, so let's make them short, please. Okay, do we have a microphone somewhere? Please help, otherwise you're going to have to, you're first. Yeah, hold on. Okay, go ahead.
Shout it out.
So
Yeah. So really quick, I guess the question is about metrics for open
Yes.
source and how do we know open source is having an impact? And I think there's a couple quick ones, and I'll keep this quick and we can keep going. One is, interactions with open source are measured through tools like GitHub, so people who star open source projects, et cetera. And I think the other, probably more meaningful metric is the number of different companies that are making contributions to the open source. So we've got a couple like Kubernetes, Apache Beam. All of these you can see and even graph the number of different contributors and different companies coming together, all investing time and effort into improving it. I think that's a proxy for the value perceived by those companies. They wouldn't be paying their employees time to contribute new code to these projects if they didn't see impact for themselves. In automotive, I'm not as aware of specific sort of open source initiatives because what a lot of at least we're engaging with is kind of a layer below that in more horizontal technologies. So I don't know if anyone.
There are a few. I can answer that question. One, if you think about Cloud Foundry, for example, if you go to the summit, the next one I think is next week, and it's it's in Switzerland, Richard, I think. You'll see that a number of automotive companies are going to be there, and a number of others. So that's an example. There are a number of other ones around the tooling. Given the time what we have, we can take that offline, I promise you. Let's move to the next. There's another question here, one more over there, and then here, go for it, please. Yeah. But I'm not dismissing it. That's a really important question. Yeah, we should cover it. Please.
Well, thank you. I just wanted two very, very quick things. One of them, Preston, I would really like you to talk just briefly about Android things and how it connects with the rest of the stuff that you've been talking about. And the other thing is that in Barcelona, for example, I'm originally from Barcelona, we had self-driving metro in the 60s. People were really, really, really scared of it. So they had to cancel that thing. Today, the metro in Barcelona is completely automatic, but they still have drivers on most of the lines. They only close the doors. The new lines, the one that comes here, has no drivers. And people think that is normal. So how do you see the changes on the mentality of people accepting technology in all these things like autonomous cars and other
That's a big
vehicles?
question you're asking,
Yeah.
but it's important. I like it.
I'll
Preston,
spend
you want to answer the
10
first
seconds
one?
on Android things. I'd love to hear him talk about public transport.
Alex will answer the second part. Yeah.
Yeah, so in brief, Android things is really just another flavor of Android, very similar to what runs on the phones, but tailored to IoT devices. Find out more, you can come by and we're happy to talk to anyone more about it.
Yeah.
Alex, briefly, yeah. Then I want to take the other two questions.
I think I'll speak a little bit on the public transport.
Yes.
Definitely something sorry. As far as public transport goes, it's definitely going to be around for the near future. I think one of the big questions right now as far as autonomous vehicles goes is whether it's going to go for the entire trip, which is scaring people who are worried about the furthering of the urban sprawl, or if it's going to be more of a last mile solution that you might take a subway from one part of Barcelona to another, and then you just use an autonomous vehicle to take you from that last stop back to your home. I think that's probably what's going to happen as far as public transport.
So this is work in progress, and reach out to them offline, please, okay? Bill Hoffman, you had a question? And then one last question in the back, I promise, I'll take it, yeah.
So how are we going to reconcile these autonomous vehicles with my classic cars?
You mean you want us to allow you to drive? Who wants to answer? Ankur, maybe you can take that, yeah.
Well, I think we were discussing just before this session. I think, the full mass deployment of autonomous vehicles.
Ankur, be careful because he loves to drive, though. You got to really tell him that, yeah.
Will probably happen in a greenfield scenario, right, where you kind of build the infrastructure grounds up, and we are discussing. I live in Dubai. Deserts kind of sound like a very good place for such sort of things to really happen on a mass scale. But I think in the other way, it's not just a question about technology, but broad raft of things, including policy. So probably not a very straight answer.
Excellent. So we'll let you drive for a little while. One last question in the back there, and then we got 13 seconds. Can you do that quickly?
cybersecurity for Alex. I think car being very rich as an IoT environment, a lot of information, a lot of connections, big attack surface. Will we have to accept that there will be only one single entry point to the car from a cybersecurity point of view?
That's a good question.
That's a good question that requires more than 9 seconds to answer. I am not a technical person, but there's quite a few entry points that you could tackle as far as cybersecurity goes, such as the question of hacking the car itself, going through whether it goes through one of the networks, whether it be short range or long range, a man-in-the-middle attack that makes the car misinterpret a sign. There's quite a different ways a cyber attack could go into a connected vehicle, which is why we need to be very careful with it in the future.
Thank you, Alex. Please join Alex offline to talk a little bit more about it. Please join me in thanking my colleagues here. I hope you all enjoyed this panel. Thank you.